paranoia that like chases me down every night before I sleep, where I like remember one stupid mistake that I did.
You realize that you only got like the last sentence of the recording or something.
Yeah. Awesome. So I'm just refreshing everywhere to make sure we're live. Amazing. I can hear a double echo, which means we're live. It's always this terrifying experience, honestly, where, like you want to hear the echo, there's this 30-second delay, and like I'm freaking out because what's going on? Why am I not live?
I just got the LinkedIn notification, so don't worry.
That's good to know. Awesome. I'll start by introducing Mark and the series, and then we'll start by interviewing Mark about his journey. So, welcome back, everyone, to whosoever is joining us live, and thank you for anyone who's watching the recording. Uh, I'm super excited to be talking to Mark today. Mark, solo silver medaled on the 33rd position in the Petfinder competition, and we'll be learning about his solution and his journey, like always. This is the 8th Chai Time Kaggle walkthrough. So if you're new here, we've been doing this for a while, and my goal is to always try to understand the brains of awesome Kagglers and understand how did they get to the top of the leaderboard, how did they get to where they are in the journey. So if you want, you can also check out the other videos in the playlist, although I really encourage you to Kaggle more than just watching the videos instead. So why am I doing this? What's the reason behind this? This is part of Chai Time Data Science 2.0. Chai Time Data Science was one of the top streamed Kaggle podcasts where I used to interview my Kaggle heroes. And this is a step further in that, where I also try to understand the solutions. We also try to understand machine learning frameworks and deep learning papers. So it's a more holistic approach, in my opinion. And I'm interviewing Mark today. Mark has just achieved the title of Kaggle Competition Master. He's a senior data scientist at 84.51 degrees. Am I saying that correctly?
It's 8451, but I could never blame anyone for getting that wrong.
Okay. And you can find him on Twitter at his first name concatenated with his second name. I would highly encourage everyone to check his Twitter out. He posts very insightful stuff there. Mark, thanks again for joining us today. And I'm super excited to be talking to you.
Yeah, it's an honor to be here. I love the show so much, and I'm so excited to get into it.
So I want to start by asking questions around your background. And I saw that this is not financial advice for anyone, but are you buying the dip? This is in the third week of January for whoever's watching.
Dollar cost average. That's what I'll say. Just keep
DCA.
buying. Yeah.
Mark has a background in the blockchain world as well. That's why that question came up. But can you please share how did you get started in the world of data science? Because I saw that you come from a mechanical engineering background and then you made the transition. Was the transition hard for you? Because I really believe being from a computer science background hasn't helped me at all. I might be really stupid, but how did you make the transition? How did you go about learning all the things?
Yeah. So, like you said, I started off in mechanical engineering, went to University of Michigan. And while I was there, they have you take this freshman year computer science class where you basically go through, C++ and MATLAB. And, I appreciated it. I appreciated how powerful it was, but I didn't really like it. I was doing all this programming. It felt like for the sake of programming, and I didn't really feel like I was accomplishing anything. So kind of threw it to the side. I wasn't really that interested. And fast forward to a couple of years from that, I was doing a co-op in crash testing with Toyota. So I was basically entirely on the mechanical engineering side of things, but I was running these huge simulations to see how our cars would do in a crash test. And they had a Python script that would take those simulations and batch them up and send them off to a server. And they had this weird esoteric error. I think it ended up something to do with file paths or something, but they didn't have any time to look into it. And so they asked me if I could do it. And I said, well, I have a semester of programming experience years ago, so maybe, but no promises. So I looked into it, and I ended up figuring it out. Fortunately, it was easy enough that that my lack of experience could still figure it out. But um, I kind of got hooked because I realized that I loved the sort of the problem solving method I had to go through to figure it out. And so in my free time, I started taking Python courses, whatever I could find, Code Academy, just whatever I could find on the internet. And I liked it so much, I saw that this class the next semester that was about self-driving cars. And University of Michigan is very close to the big three auto manufacturers in the U.S. And so they had, it was a very inspired course. It was sort of a progenitor for courses like that. And little did I know it was a graduate level course that I somehow got into because I was a mechanical engineering student. I guess they were letting undergrads in, and so I got smoked by this class. Like I'm not gonna sugarcoat it. Fortunately, I took it pass fail, so I didn't have a grade letter associated with it. But it went through everything from nonlinear optimization to convolutional neural networks, and I really was inspired after it to learn more about it. So I just went down a rabbit hole. I mean, I could not get enough of it. So you ask if it was difficult. I don't know, because I spent so much time working on it that I was going to figure it out one way or another. It took me some time, but I had spent so much time by the end of it that I was more interested in data science than I was mechanical engineering. Even though I loved mechanical engineering, I spent so much time building robots and whatnot. So initially, when I was looking for jobs, I was looking at smart manufacturing companies and anyone that would want someone from a mechanical engineering background, but not necessarily like a pure data science background, but would allow me to flex that. And none of it really jumped out to me, and it didn't really seem like most of the positions were hiring directly out of college. They wanted people with more experience. And so I came across 8451. For American viewers, it's a wholly owned subsidiary of Kroger. We do basically all the data science work for Kroger, which is one of the largest grocers in the US. And it's headquartered in Cincinnati, and that's where I'm from. And so it was appealing. It was a familiar area, familiar company. And, I searched around and saw that 8451 had this phenomenal development program where it was basically like, we care more. Of course, we want people from some sort of a data science background, but we care more about people with the mind. And it's like, we just want the people that have the mind for this and are good communicators and whatnot, and we will teach you. And I said, sign me up. So here I am. Yeah, that's me.
That's awesome to hear. Where did the passion for keeping art programming come from? Because my interactions with my peers from like a mechanical engineering background is they usually condescend programmers. They think like it's the stupidest job ever. Where did your interest for that world come from?
It's hard to say. I mean, I think it just hit me perfectly at the right time in my life. My brother is in cybersecurity, and he was much more of a programmer throughout his life. And so you could just say I just had the brain for it and didn't realize it or something, or maybe it was something that was always going to reach out and hit me in the face at some point. But I think that what I like is building systems. That was one of the things that I enjoyed the most about mechanical engineering was you're building a robot, and you have to break that robot into a million components. I mean, not literally a million, but a ton of components. I mean, you're in a CAD software and you're designing, like some pillow block that goes on the undercarriage that you won't even see. And then you have to take all of those, put them into a big drawing to see if it works. And then you have to go hand manufacture every one of those. And programming is just a giant analogy to that. We'll get into the code for this solution later, but I program like that too. I love to break things out modularly and then build them into this one big solution. And I think that one of the exciting things that really drew me into data science specifically that I didn't get in mechanical engineering is that, or I guess I kind of got it, but I love the sort of inexactness of everything. It's like the reason we're training a model is because we can't figure out how to write code to do it. So, you're taking all this complex system and putting it together to build this thing that solves an incredibly complicated problem. And that just really speaks to me.
That's awesome to hear. You were also, I think, trying your. So this is me trying to look at your LinkedIn profile and figure out the timelines. But from what I understood, there you are also trying to build your own business as well. I believe you were a CTO of a startup in the Ethereum world. So tell us more about that. Versus also passion for building products and stuff like that?
Yeah, so that was kind of a college thing that never really came to fruition as much. But it was one of my original forays. After I figured out, how to do predictive modeling, I was interested in any way that I could apply that. And so I saw that, the crypto world was in absolute chaos and markets going up and down. And I figured, heck, why
Nothing's
not?
changed
Why
though.
don't I know that nothing really has changed, but so I started, it was anywhere I could apply stuff. And so a couple buddies of mine got together and we were like, what can we build? I don't know, everything. So it's kind of I would call that sort of a young and dumb sort of experience. But I learned so much about data science from that. You could take blockchain out and replace it with anything. It was just my first experience really getting to apply data science and programming and databases and all of these different things into initial products.
Did you also gain some software engineering experience there? Because that's one part that data scientists just skip and jump ahead most of the times.
Yeah, and again, coming from an engineering perspective, that's like when I took 2 classes in college, and both of them were basically CS classes. They were software engineering classes, and so that's the perspective I come to, especially Python from. I appreciate Python for what it is because it's not the C-based languages, but I still program a lot of Python like it's one of those languages because I think I just appreciate the rigor. And one of the issues that you have in data science is it's really hard to experiment quickly with new things. And I tweet about this all the time, that the best models come from rapid iteration. And the best way that I found to rapidly iterate is to build very modular project structures where you can quickly swap in and swap out new things. And I know that a lot of Kagglers will build everything in this sort of intertwined Jupyter notebook. Not there's anything wrong with notebooks. I love notebooks, but what I found is that it's so important for me to separate everything out into its own little modular bits so that I can quickly swap in and out new parts and see what works and what doesn't.
Yep, that's one thing I've learned from Kaggle. They're super fast at prototyping, and I from what I've been hearing, it's really useful in the industry. I just create content, so I have no idea what I'm talking about. How did you get how did you get passionate about Kaggle, and how did your Kaggle journey begin?
Yeah, I'm an absolute nut for competition. I played sports my whole life. I played club sports in college. And I was a baseball pitcher, and an outfielder, and so I love competing however I can. But really, like, I shouldn't even say that I got into it because of the competition. I more so got into it because I saw, I can't remember what my first competition was. If it was I think it might have been the NFL rushing yards prediction competition from a couple of years ago. And I got into it because it was like, hey, here's an opportunity for me to use data science on a problem that interests me. And I started reading. I had read some past solutions to past problems, and I was like, this is an incredible learning resource. This is where I want to be. I mean, it seemed like I didn't really realize how true this was at the time, but it seemed like this is the place where things happen. And I want to be a part of it. What you'll find is that that competition isn't on my page because it was a reruns competition, and I ran out of time in the private leaderboard submission,
Okay.
which is disappointing because The cross-validation was really accurate, and I was in silver medal range. So if I had gotten a silver medal solo in my first Kaggle competition, that would have just been like, that would have been great. But no, I had a humbling experience.
I can imagine your frustration. I got a huge shakeup in my first competition, and I don't want to talk about that, so I'll shut up.
I genuinely couldn't even go to Kaggle.com for at least a month afterwards. I was so embarrassed. So embarrassed.
So from there, how did you go about learning and solo gold bagging a medal on the MLB player digital engagement forecasting competition, and also solo meddling across the recent Petfinder competition? How did you learn? How did you go about improving your skills? One thing I always remember is that frustration that I had, which still hasn't gone away, which is you see yourself on the leaderboard, you think of the greatest idea. Let me rephrase it. I would think of the greatest idea, I would submit, and I will be like in the bottom half of the leaderboard. So
Yeah.
how did you improve, if at all you face that feeling?
Yeah, I mean, it was really, it was very overwhelming at first. I mean, I cannot even express how, people often talk about Dunning-Kruger, where it's like you think you're a genius at first and then you fall off. For me, there was no I'm a genius. I was at the bottom for the whole time. And it was a lot of me just bumping around in the dark and reading Kaggle solutions, reading blog posts, reading research papers, figuring out, I mean, like reading a ton of old Kaggle solutions where I would go to a competition page and take a quick glance at the data and just see, okay, how do I think I would solve this problem? Yeah, there you go. There you go. You took the words right out of my mouth. But it was just so much practice and just trying and failing and trying and failing and trying and failing. And then I would say the real breakthroughs for me came. I know you're a big fan of the Fast AI course, and I watched probably 2 or 3 months after the lectures were posted on YouTube. I watched the 2019 version of the Fast AI course, and it all clicked. I mean, it all clicked. Like Jeremy Howard teaches in a way that just resonated with me. And I don't use Fast AI to this day, but the way that he taught that course was so revolutionary for me, because not only, I mean, I would recommend it to anyone. It's probably, in my opinion, the best deep learning course, that holistic deep learning course to go from kind of zero to hero out there. But it was particularly for me because he really teaches it in sort of a systems way of thinking, and an intuitive way of thinking. He doesn't teach you the atom optimizer in terms of like, okay, here's the code, figure it out. It's like, okay, well, we started with SGD with momentum, and then we figured out we can improve that with RMS prop, and then atom, and here's the intuition. Here's why they came up with it, not some super technical definition.
Yeah, as you said, I'm a huge fan as well.
Yeah.
So from there, how do you today decide which competitions to take part in, transitioning to about the Petfinder competition? How did you decide that this is the competition I want to spend a few weeks on? Even though I want to point out to the audience, you just spent a really small amount of your time, which is like 2 to 3 weeks compared to the, I think, 3 or 4 months for which this competition ran for.
Yeah, so there were combinations of factors for this one, but generally speaking, I think a lot of Kagglers think the same way, but it's just finding competitions where I feel like I can learn something new. Generally, I try not to throw myself into something that I'm going to have absolutely no base of knowledge on at all, which really isn't really anything anymore. I think that was more so a year or two ago, where there were entire fields of, say, deep learning that I had never even forayed into. But it's really finding something specific about a competition that I really want to learn, and then I just jump in. Like I don't let myself back out, because the human mind, as soon as we hit something rough, we're much more likely to just shy away. And so I try to just dive in head first. And for this one, the combination of factors was I was extremely busy in my life when I started, but I really, really wanted to do a Kaggle competition. And so this one was something that I knew I could focus on one specific thing. It was a very straightforward competition. It was just, here's some images and you're predicting a regression target. Very straightforward, but I could tell immediately it was going to be, how good is your cross validation, and how good is your experiment tracking? Because with the exception of a couple people, everyone was ensembling these huge ensembles, and so I could just see it from a mile away. And so I started using weights and biases during the gravitational wave challenge, which is the one I did prior to this one. And I realized how powerful it was to have a really good experiment tracker rather than, I was using TensorBoard before, which is fine. But it requires a lot more manual effort to get kind of what you get out of weights and biases. And credit to Google for putting that out there, because there was basically nothing like that before TensorBoard. But then I realized what a quantum leap it was, just how much more you could get out of it. And so I realized this is going to be where I learned that. And I still suck at it. I'm sure that if you went and looked at my weights and biases dashboard, you would have to shield your eyes because it's just not well organized. And there's probably more I could put on the dashboards and whatnot. But I learned so much about how you should use how you can essentially use big data on, like, meta big data almost. You can collect all this data about your training processes and know what to do differently in the future, quickly figure out if things are working or if they don't. So yeah, I mean, that was specific to this one, but again, it was just about finding something that I found interesting.
No, thanks for the shout out. And I'm pretty sure no one from the team watches my video, so I can say this safely. But I'm myself learning the framework a lot, and yeah, there's like many interesting ways, not just one obvious way, especially to track stuff. And every time I speak to a colleague, I'm like blown away. Oh, I should have known that feature. I can't believe I've been here for a few weeks and I don't know of that.
Oh my gosh. Well, I mean, there's so much. I mean, it blows me away. I found from one of the tutorials, this like image logging callback for PyTorch Lightning, which is what I mostly use. And it blew me away. I mean, I could just, a simple little callback that,
One
was
line
probably
that takes care of everything.
right. It was just done. I had a histogram plotting for my prediction distribution. I didn't even have to do that on my own. I mean, I did it. It was set it and forget it. I did it one time and I never had to do it again. And I think we all have these issues with being lazy down the line, where that you need to set, like, I need to write an error analysis script at the start of the competition, or else it's not happening later. I'm just going to get lazy and be like, I think it's doing all right. I don't really know. And it really reinforces those best practices.
That's great to know. Awesome. So coming back to the competition for the next few minutes, what I'll try to do is painfully try to summarize the overview of the competition. And Mark, please correct me wherever you think I'm wrong. So for the audience, I'll try to explain what the problem is. And the problem is quite simple. You have to look at cats and dogs images. And from there, you need to predict how popular, I love that, they can be. And you need to, I believe, predict their popularity score. So that's the regression problem that I believe Mark was talking about earlier. For doing that, I think I'm not too sure, because I might have forgotten I participated in the older competition. These were meta features that we were trying to predict, I think, by our models. But this time you got a lot of metadata around, is the subject in focus, are both eyes facing front or near front with at least one eye properly clear. These are like things, if you sit back, I believe, and think about, this is what makes pets cuter, right? And Petfinder, I believe their mission is to help fast track pet adoption. So they really want to figure out how can they improve that and what makes pets popular. So if their face is in the center of the photo, if they're nearer to the camera, if they're this focus inside of the image, you had all of this metadata along with all of these images in the I need to refresh that. I'm not sure. Have you been around Kaggle during those days when it just used to crash a lot?
Oh yeah, I think I got in just at the tail end of that, but yes, I know exactly what you're talking about.
So it's definitely much better now. But as you can see, there are a lot of images. This probably, I'm guessing, wouldn't help fast track their adoption. So we need to help them understand through using our models which pets can be adopted faster. Have I summarized this correctly?
Yes, the only thing I would add, and we'll get into it later, is just how noisy the target variable is because it's a derived metric and it's tough. So as cute as the name popularity is, it really it grew some gray hairs on my head.
Okay. So from there, I'd love to understand how did you approach modeling? I remember my colleague Aish Thakur had put out this incredible kernel on Efficient 8 V2. There was another Kaggle Grandmaster. I'm trying to find that among the million tabs that I have open, who had put out a starter kernel on Efficient and BNet, a
Mhm.
B0, which had this nice dashboard, and they were trying to showcase the gradcam of, hey, Efficient net works well, and this is what it's actually detecting inside of the images. So how did, when you saw the problem, how did you approach it? What was your baseline and what were your first thoughts?
Yeah, I mean, I think that the simplest baseline here, because it's an RMSE competition, was just what's the standard deviation of the target. There was a lot of conversation at the beginning, like very beginning of the competition, which was like, are our models even learning anything? And you couldn't really tell because it was a pretty high RMSE. I mean, I think anyone who looks at a competition where the target is 0 to 100 and your RMSE is like 17 sits there and wonders, am I really learning anything? But my benchmark for it was just what's the standard deviation of the target, and it ended up being 20 or so. So you can use that to say a totally naive model would have an RMSE of about 20. So I started there. Um, and normally I would do a little bit more complex benchmarking, but I had seen early on that the metadata didn't really seem to provide a ton of value. I think that Chris Diot had a good solution where he also used the metadata, but most people I don't think did. And so I at least searched out to see if anyone could just use the metadata to predict the target. And what I saw was the solutions that only used the metadata were about at that 20 RMSE. So that was pretty dead to rights confirmation that the metadata was just not very useful. So I kind of proceeded at least at first without it, and I just did what I would do with any other competition, and I set up a super simple model with a validation set that seemed to make sense to me, and just through PyTorch image models, the wonderful Tim repo, and just got it like a ResNet 34 baseline or something like that, and the cross validation was super important. I spent a lot of time on that for this competition, as I found out very quickly. If you went through a bunch of the notebooks, you would find some sketchy validation, to say the least. So I would say that my start was just get the stupidest baseline I could out with the simplest data augmentation, and then iterate on my cross validation. And the way that my timeline worked for this competition was I spent probably about a week at the beginning of the competition actually working on it, and then for the last 2 weeks of the competition, I actually took it seriously and modeled. So there was a almost 3 month gap in the middle where I did nothing. So the first week was just me figuring out what made sense to me as a validation strategy, because the public leaderboard really wasn't helping with that.
Where did that intuition come from? I'm really curious because even like you mentioned, whenever you go to the discussions, there's this, now it's solutions, but during the heat of the competition, people are sharing so much stuff. First of all, because it's incentivized, they would appreciate the upvotes, they would get medals. There's also so many kernels. And one thing I've learned the hard way is not all of them are the best kernels. So how did you sift through these? How did you understand what's probably what's the one thing you can take from here and what should you do yourself?
Yeah, so I tried to. I mean, you read Kaggle discussions enough, and it's almost a meme. You know, CV greater than sign leaderboard or whatever. You know, people, all the most successful Kagglers repeat that. And so if everyone who's having success keeps saying something, it's probably worth at least looking into. And now I will say I haven't really participated in a lot of competitions seriously that had massive shakeup. So I haven't really, I don't know if I had fully taken it to heart, but I at least knew that I I had to appreciate it. I mean, I think the only one on my competitions page that really had shakeup was the M5 competition, and I only worked on that one for maybe a couple weeks before I lost interest. So, you know, I just understood its importance, especially because I was looking at a lot of kernels and just thinking to myself, this doesn't look right. There was a very popular kernel that was they didn't even I don't even think they realized that they weren't doing cross validation correctly. They were basically, I don't want to disparage anyone because I think it was one of their first kernels posted ever, which is like, if you can even get yourself to posting a kernel, like props to you, because I never do. But I think they were basically taking a 20% random sample over 10 folds. And so they were doing basically bootstrap cross validation, but they weren't doing it in a way that you could rely on the cross validation score, but it was doing really well on the public leaderboard. And so
Hmm.
what I said to myself is, yeah, I mean, that ain't right. You know, there's something wrong here. So I think I realized pretty early on, based on all of that, all of those sorts of piecing all of that together, that cross validation was going to be super important here. And it did end up being, I think I was 400 something place on the public leaderboard, and then I ended up in 30th. So it looks like my starting intuition was correct.
Were you surprised by that at all, or were you expecting that? Because
Yeah, you should
that
ask
is a
my
huge jump.
girlfriend. I think right after I saw it, I shouted, and my girlfriend went, "What? Are you okay?" Yes, I'm very okay, actually. So yeah, I was shocked. I mean, I think I had maybe a little bit of an ego going into it. I think I knew that what I was doing was pretty solid. I was looking at my cross validation scores and thinking this looks pretty good. And when I look at public leaderboard or public kernels that are actually running good cross validation, I was beating their scores. And so I knew there was at least something good, but I thought, maybe I'll get a bronze. I don't know. Um, you know, when you put that little time into a competition, you don't really have high expectations. So I was thinking, you know, maybe I'll snag bronze or something.
But congratulations again on the solo silver. I know that pushed you up to the masters ranking, so that's really awesome to see.
Appreciate
For
it.
the next bit, I would request you to share your solution overview, and I believe I'll hand over the screen share bit to you for that.
Yeah. So before I get into it, I'll just kind of talk over what I did. So I for most of the competition, I was doing fivefold cross validation, and basically the way I set up my validation was something I saw actually fairly early on from a legend in the Kaggle community, Phalanx, who is an absolutely incredible at vision competitions. But what you could notice about the target was that despite the fact that it came as a floating point number, it was just integers from 1 to 100. So you could just do stratified k-fold on those integers. So instead of doing the common sort of, I always credit Abhishek Thakur with this sort of methodology of binning regression targets and then stratifying on those. I'm sure that somebody else came up with it before him, but he's the first one who I saw posting about it. Instead of doing something like that, which a lot of people were, I figured why bin an integer target when you could just immediately stratify off of it. So I found that it made sense to me. Again, there was no public leaderboard feedback that you could get from this. In fact, it seemed like sometimes the better my cross validation got, the worse my public leaderboard score got. So it was frustrating, but it felt like it made sense to me. So I went forward with it. The The second part of the solution is that transformers and any model that did not rely on batch norm generally did really well. So I noticed that not only did my Swin transformer model do well, and I tried Convit later on, and there's one more I'm forgetting, but NFNet did really well. And the TIM library has this wonderful ECA line of NFNet models that are essentially a more efficient implementation of the original NFNet models, because those NFNet models are beasts. So I found that all of those worked well, and I'm, looking back on it, I'm really disappointed I didn't use that intuition more effectively, because I know Chris Diot found that if you just freeze the batch norm, then you could use any model. In fact, he just used an efficient net. So I wish I had figured that out. But nonetheless, I found a few different types of transformers that worked well for me. And go ahead.
Sorry, I was just going to interrupt and ask, how are you going about discovering these? Because even if you go to, like, let's say the Hugging Face or TIM repo, TIM has like 500 models at this point. How are you selecting these?
I'd love to say I did something more scientific, like, literature analysis and whatnot, but really what I did for a lot of it was the Swin transformer had been posted pretty early on, so that was pretty easy. But I just kind of went through the models folder on PyTorch image models and said, oh, that looks interesting. And then I clicked on it and said, is it a transformer or does it not use batch norm? If that was true, I gave it a shot. It was pretty simple, honestly.
Gotcha. Okay.
Yeah. Normally I do more research, but that was that. So I kind of had a moment where I looked at the clock and said, I better figure out something to differentiate my solution, because I didn't really think that was going to do it. So the two things that I did were, first, I upped from my 5 folds to 10 folds, because that just kind of helps final leaderboard scores. And then the other thing was I went back to the previous Petfinder competition and grabbed all of the train and test images, and I pseudo-labeled them. That was another opportunity that I felt like I had for learning. I had never gotten pseudo-labeling to work for me, but I found that when I included all of those images, I tried to do all kinds of things with filtering out bad images or whatever, but none of it helped. But what I found was that including those images really helped my cross-validation, like significantly. It was about, a 0.1 or 0.2 improvement for all my models, which for this competition was very, very significant. So what I did was I basically reckoned in my head, how much time do I have left in the competition? How many models do I want to train? And I saw how long pseudo labeling was going to take. And so I set up a giant run script to get all of the pseudo labeled models to run, and then leave enough time for testing and whatnot. And I had, the original end date was on a Thursday, and Kaggle had some issues that caused people to accidentally get banned or whatever. So they extended the deadline by a day, and thank goodness, because I would have barely beaten the initial deadline.
Did
but
you
having
get banned
that extra day,
in the temporary issue?
No, I didn't.
No? Okay.
Fortunately, I didn't. But I was so glad that people did. I cannot even tell you, Sanyam. So I finished up all the models just in the nick of time, and I have this linear ensembling script that I use for all of my competitions. Threw them all in there, got optimal model weights, and submitted it with absolutely no expectations.
Amazing.
So yeah, so I can go into my solution a little bit more in detail. Let me pull up the GitHub.
I was almost tempted to start a thread where I could like farm a gold medal of the competition deadline extension memes.
If anything like that is meme gold. I mean, I think that some people on Kaggle should be competing for memes rather than anything else, because they're so good at it. All right, can you see the GitHub window?
I can, yes.
Awesome. So here's my my repository, that it looks like I just threw everything into a bunch of Pi files, but I have a few directories that I git ignore because it's where all the data and checkpoints and stuff are. But I would say it all kind of starts in the train script. I can sort of jump into other scripts from here. But this is when I said that I got that that big run script together. It was all facilitated by the fact that I have this one master Pi file that has all my different command line arguments that I could just orchestrate a giant set of runs together and have it run. And that's one of the things I like more about this sort of setup than running out of notebooks. There are solutions to batch notebooks, but I just find that, eventually I like to get to a point where I define all of the knobs that I'm going to be tweaking, and then I
Sorry,
just
could you
make them
please
command
zoom
line.
in a touch? I think
Yeah.
that's perfect.
Is that
Thank
better?
you.
Awesome. So I kind of define all the knobs that I'm going to be tweaking, and then I make them command line arguments. You can see I have a bunch up here. And so what I did to make this sort of tractable to keep all the experiments in my head was, as we scroll down here, I define my weights and biases logger here. And you can see that I basically just named my models. What's the class of model? What seed am I running it on? What's the sort of experiment name? And then I delineated, hey, these are my tenfold models. And so that's what I mean when I say that experiment tracking was absolutely completely necessary for this. So nothing really exciting from here on out. I just run the trainer, PyTorch Lightning trainer. Shout out to PyTorch Lightning, my favorite deep learning library. And then log some final metrics with weights and biases. So I can get into my model definition and kind of talk about how I set that up, because that's another important part of this. So what I did here was I set up a model that was just built around all of those knobs that I'm tweaking. You can see all the arguments here are just hyperparameter tuning bits. So everything from model dropout to stochastic, stochastic depth, mix up parameters and cut mix, and then whether or not there were a lot of people that treated the competition like a classification problem, since it was like bounded regression, and that's what I mean here. And that is something I did along with just about everybody else. And then I set up a class, this backbone class. Not really that interesting, because Tim create model, the PyTorch image models library basically takes care of this for you, but I didn't really understand that at the beginning of competition. So I just set up a backbone that could take any model name and form it into a CNN Vision transformer backbone, pooling, and a simple linear head. And that was really all there was from a modeling perspective. Every one of my models followed that very dead simple, as basic as it gets structure. And then from here on out, it's just defining whether or not I'm doing pooling based on whether or not it's a transformer model. I'm sure there's a better way of doing it. And then just, here's my optimizer, here's my training step, here's my validation step. And then here's how I did some more experiment logging. I mentioned before that I plotted my prediction distribution using weights and biases, and that's just me doing that right there. Directly copied code from a weights and biases collab. Very proud of that. And then I have some other things down here that I didn't end up using, but I subclassed my initial model and made a model that just returned the step before the head in case I wanted to do some support vector machine boosting. I'm disappointed I didn't find a way to make that work better, because a lot of the winning solutions did that, including the number one solution. And thanks again to Chris Diat. I think I mentioned him 3 times now, because he pointed that out early on in the competition.
He's an absolute legend.
It's incredible. I mean, I've learned so much from him. I should probably pay him 40 grand or something for a year's worth of master's level education. And then I have a sort of not very interesting validation script that I use to actually generate out of fold predictions. And then I throw all of that into this out of fold optimization script. The guy I cannot remember his name specifically. I think it's Yurun Zhang who was working on, I cannot remember, it might have been the mechanisms of action competition. And he put together this sort of out of fold optimization framework using SciPy. And I have used that in any competition I can use it in from that point on. And so I just throw everything, all of my out of folds into this one dictionary. And then I just use the SciPy minimize to figure out what the optimal weights for an ensemble are. And you absolutely can do it for RMSE using, I think it's called Big Chaos, the Netflix solution. They did all the linear algebra to figure out the sort of optimal equation you can use to solve it directly. I already had this set up, so I didn't really bother figuring that out, even though in retrospect, I probably should have, because it's probably better. But so I use this out of fold optimization to figure out how to blend all my models together. And yeah, I mean, that's really it. I guess I can show the run script, what I mean. I have a lot of it commented out because I was just rerunning some that failed, but this is how I would run it. I would just say Python train ECA NFnet with this name, with this learning rate, this weight decay, this batch size. As you can see, I have a puny little GPU. I just have an RTX 2070, so I could just get 3 in my GPU at once with 512 by 512 image size. And I trained on 3 different seeds. And I did that with NFnet L2, Swin base 384, Convit small, and then Swin large 224, which isn't in here right now. And then, then I guess I should say, I have just a modified version of the train script to do pseudo labeling on. This is the last thing I'll point out, where basically all I do differently is first I load. So if I'm training on folds 1 through 9, or 1 through 10, 1 through 9, I load in the model associated with that training data. So I load in the model that was trained on the competition data, folds 1 through 10, and then, 1 through 9. And then I make predictions on the pseudo label data, so the data from the previous competition, and then I just concatenate that in with my training data, and then train a new model from scratch on all of that data. So that was how I did pseudo labeling. But yeah, that's the whole thing.
It's such a beautiful solution, because I know many Kagglers, not to crap on anyone, but many people wouldn't even put in the effort to structure it so nicely, and it's so nice and modular and really easy to understand as well. I think that's one of the really awesome things in your solution.
Yeah, I've been bit enough by solutions in the past where I'm scrolling through like 1,000 lines of code just to get to the part where I train my model, and it drove me so up the wall that I just couldn't do it anymore. I had to do it like this. I can't do it any other way anymore.
I'd love to also understand, how are you using weights and biases here, and how are you tracking your experiments, if at all? How was that useful, if at all?
Sure. I'll open up my dashboard, but I'll caveat it with gore warning or something. This is R-rated. It's going to be a little disgusting. I'll try to hide because I'm using it for a new competition right now. So okay, I think we're on that competition. Let me zoom this over.
You're not sharing your screen right
now.
now.
I know. Yeah, I'm just making sure I don't share anything sensitive yet. Sure. So share screen. Okay. There we go. All right. Can you see my weights and biases screen?
Yeah, I can see NFNet, which means I don't get any
Awesome.
secret information.
Yeah. Awesome. So basically, you can see the charts over here. I was just charting. There wasn't a ton of metrics specifically to log as far as plot worthy ones. So I had my RMSE loss, which was the actual competition metric. But as I mentioned before, a lot of people were treating this as a classification problem. So I guess I can dive into that a tiny bit more to make this make more sense. But when you have a bounded regression problem, so in other words, it's never lower than 0 and it's never greater than 100. One thing that I've learned, it was brought up in the Fast AI course, and it was brought up a lot at the beginning of this competition, is a nice thing to do is to actually run a sigmoid on your output so that you can have a sigmoid that basically bounds it between 0 and 100 or 0 and 1. And so you do that, and then you can train it on RMSE, but I found it worked a little bit better to optimize on binary cross entropy and just treat it like a classification problem. So that's where I was logging this over here. I didn't really pay too much attention to this because RMSE would show basically the exact same sort of shape.
Makes sense.
So I'd say the best part about this, the two best parts is, or if I click into one of these, you can see that I have the prediction distribution over time plotted out. And so this was really nice just to sort of see, are there areas of the target distribution that my model just isn't really picking up on? And as you can see, again, it was a really noisy metric. So you can see the prediction distribution shifting around over time, but generally this looks like the target distribution. By no means is that saying that you have a perfect solution. In fact, it'd be very surprising if your prediction distribution didn't look like the target distribution, but it's at least a good sanity check to make sure, okay, I'm actually learning something here and my targets aren't corrupted or whatever. And then another great thing about this is because I am running it from the command line, both I can also see how it's going in real time if I'm on my phone or whatever, but I also could go to the overview and see, I trained this, forever ago, and I forget what parameters I use. So I could just go to my CLI, my command right here and see. Yeah, I could just say, I'm using pseudo train, which means I'm pseudo labeling this. Here's the model class, here was the experiment type, and here were all my hyperparameters. So that, it's just invaluable. And I was using Colab to train a lot of the models. So I could see, because I'm using a P100, that means I was in Colab. So it was so invaluable for this. I cannot recommend people try it enough.
Awesome. Thanks for the kind
yeah.
words. I'm sure the team will really appreciate it.
Of course. But there's one more thing. I hope they appreciate it because it's a great piece of software. But I was naming all of my models things that were easily searchable. So I would name, all of the relevant experiments like random resize regog. If I search that, you'll see all of the models that went into my final solution because they were all based on the same augmentation and experiment setup. So it was really, really easy to filter by the things I want. Now I know that there's a grouping functionality. I'm going to be honest, I didn't have time to figure it out. So that when I say there's gore in here, that's what I mean.
To the audience, I again want to remind everyone that Mark bagged the medal in 2-3 weeks worth of efforts, and usually you see people submitting at least 50 plus models to the Kaggle leaderboard. I just saw 17 next to his name, so that really speaks to how much he was able to accomplish in such a short time.
Hey, get it right on every submission. That's what I say.
Awesome. So I believe that concludes the solution overview. Any things you want to add here, or any things before we move on to the community asking anything?
Trust your cross validation. If I had chased the public leaderboard, I'd be in 700th place right now. Again, like I said, I was in 400 something place at the end of the competition, and I knew there was going to be shakeup. I could not have imagined it was going to be shakeup like that, though.
Awesome. That's one comment that I always keep hearing from Kagglers. So that's reassuring. Um, Someone's asking how many hours on an average do you usually spend on Kaggle?
Oh, there is no average week on Kaggle. It varies so heavily by how much stuff I have in my free time. I do a lot of stuff. I commit myself to a lot of things, and so if I have a free week, and everyone else in my life is busy, I'll spend most days after work, like just about every hour I can get. But a lot of weeks, it's like I can work on it 1 or 2 days, and then the rest of the days I set up my script so that I can run experiments in the background. And so I'm not actively sitting there. I'm just letting experiments run and seeing. Then I come back the next day and see what actually worked.
That makes sense.
Yeah.
The next one is, what is your key learning after doing so many competitions?
Oh, I haven't won any competitions, so I'll correct the commenter there. But it's a lot of it is just like, you can read a research paper and it'll tell you that it's state of the art. It's the best model out there, but there is no better pressure cooker than a Kaggle competition. I'm serious. I mean, for any supervised learning task, does it work on Kaggle? I mean, put up or shut up kind of thing. And, I respect all the researchers and the work that they put in, but a lot of it is just, you got to try stuff for yourself to see if it works. And, you can't sit there and read discussions of what other people are trying, because if it's out in the public, it's no longer going to differentiate your solution. So, I mean, with some exceptions, but you got to just try new things, and trying new things is the best way to learn. I mean, I just listened to a couple of your other podcasts last week, and I think it was Datasaurus that said from someone else that, if you didn't code, you didn't learn. And I mean, absolutely. You learn so much. You learn so much by just sitting down and forcing yourself to do it. It's super easy to go into a public kernel from a guy like Chris Diod or Abhishek or someone and just copy it and be like, all right, that works. I trust them. They work at NVIDIA or wherever. They must know what they're doing. But you will never know what you're doing unless you sit there and just do it yourself.
I saw a tweet by CPMP, who's one of the most respected Kagglers, who said, "I only join competitions where he only joins competition where he knows he can learn more, and not the ones where he can do well." And then Jiba, who's a Kaggle legend, former number one, absolute legend in the Kaggle world, replied, "I do the same."
Get out of here. No, nobody wants to talk to you. All right, you guys are too good. You're making the rest of us look bad. They're like, yeah, I want to enter to learn, and then they just win. It's like, oh, great, I won another competition.
I was trying to find the tweet. Here it is. And then somewhere Jiba replied, "Same here."
Yeah, and I mean, jokes aside, I mean, I said it, they said it. Any successful Kaggler I've seen has the same mentality, and eventually, the things that you don't know start to get reduced into smaller and smaller parts of the problem. And so the reason why they're able to say that and still win is because it's not like they start programming with absolutely no base of knowledge on the problem. There's a specific part that they want to learn. And so that's why they can still do so well. So they're incredible for that reason.
100%.
Yeah.
This is a question from me. How did Kaggle help you in your professional journey? Did it help you at work? And did you see any learnings bleeding over to the real world? I think that's a BS argument that everyone makes, that Kaggle doesn't help you in the real world. I know it does. I'm curious, how did it help you?
Model validation is probably one of the biggest parts. It's so hard, and I'm in a master's program right now, just to sort of shore out a lot of the sort of like Bayesian statistics things that I missed entering the field from the outside. And what I've realized is it's a great program. It's the Georgia Tech Online Masters of Analytics. It's like $10,000 for the entire program. I mean, you cannot get a better deal than that. But that program and every other program, they just do not teach model validation very well. And I'm fortunate to work alongside some incredibly talented data scientists. I mean, I work with people every day that blow my mind. And I think that one of the things that I can bring that differentiates me is model validation, because it's just so hard to find good resources. And you will never sit down in an academic course and be able to learn top tier model validation, because it always comes from trying a ton of different competitions and seeing all the niche differences with every competition and what you have to do to get around those problems. And you start to see it enough that things start repeating, but it's not after you've seen a lot of problems before that starts happening. That and just staying on the cutting edge with deep learning. If you aren't on the cutting edge, you will not be able to compete in a lot of Kaggle competitions. It's becoming less and less frequent in Kaggle that you're doing a competition that isn't with deep learning. There's some market prediction competitions out there that I'm not in that probably are more like GBM, XGBoost focused. But I'm sure that there will be deep learning in there. And if you always want to have a competition that you can compete in on Kaggle, you have to know deep learning. You have to know NLP. You have to know computer vision. And so being on that cutting edge has given me sort of newer ideas where if you're not immersed in your free time, you'll be a little bit behind on.
I want to go back to your previous point. Not that I actively compete. Maybe I'm just scared, but I get time to sometimes read the forums, and I remember seeing Swin Transformer on there way before the current research papers started citing it as really powerful. So if you want to really apply those models, every paper has an incentive really to, you won't say, hey, I created this thing, it's not good. No one says that. So papers always claim that this is the best, but that's how you really keep up to date with cutting edge also, in my opinion, by taking that model and testing it against others on a leaderboard.
Yeah, I actually saw in the gravitational wave challenge not too long ago, I saw a researcher who invented some, oh gosh, I can't even do it justice, but it was some like type of model that was a spin-off of a transformer. I know it was at a time where a lot of sort of Fourier type attention mechanisms were being introduced. And he had his own take on it, and he applied it to the competition and got a super high leaderboard score. And he had a YouTube video that was sort of describing his research that was up before the competition. And I saw the view count just skyrocket from the competition because, he put it out there publicly. It worked. He had a very high leaderboard position for the time, and posted publicly, hey, this is the model I'm using. And yeah, I mean, there's no better way to prove to people that your research works than go throw it in a Kaggle competition.
Totally.
Yeah.
Again, these are in random order. I'm trying to structure them best, but still they'll be a bit random. How do you, if at all, handle processing of large data sets? Any insights there?
More RAM. No, I'm kidding. You can learn a lot of tricks that are, kind of good programming practices. You'll see a lot of things like just a lot of like things like unnecessary joins or using pandas where you don't need to. It's hard to get into specifics, but not filtering properly, not filtering often enough, not understanding that Python is a garbage collected language. That's a big one for me. I run into it all the time. And what I mean by that is, you'll often have to delete a large data frame and then actually run gc.collect from the Python GC module to really reclaim that memory. And it's a lot of things. This is one of the things that you can learn really well from public kernels, because the Kaggle notebooks are very resource constrained. They're only 16 gigabytes. I think I have 64 gigs on my home machine, which all my friends who aren't in data science are like, why could you possibly need that? And I'm like, if I could get 128, I would. I mean, look, if I could get 5 3090s, I would, but I'm stuck over here with my puny little 2070. I'm getting sidetracked, but I learned a lot of that in the MLB competition, because the cool thing about the MLB competition was that they just threw all the data in the world at you. They threw everything from what day the games were played on, what stadium, what the rosters were, and then gave you pitch level data. So I mean, every pitch had a record in a data frame. And I was fortunate enough to have played with that data before because I'm such a big baseball fan, as I mentioned before. And so you really appreciate it in that competition where it's like, I need to figure out what works before I start throwing everything at it, because otherwise I'm going to run out of RAM constantly. So it was a lot of like, how do I feature engineer faster? How do I cleverly filter? How do I, how do I set up experiments that don't include that, where I can try and do things quickly, but I'm not including too much data at once. And so it's kind of where that the programming skills come into play as a data scientist. And I would say that you neglect those at your own peril.
Yeah, like you said, it's this constant things of errors that you keep learning from. I remember this is like again one of the stupid learnings from my process. I'm sure everyone knows this, but I was in the Microsoft malware competition where I was just going with the pandas defaults, and just even trying to fit a boosted tree on it would make my like 128 gig RAM overflow. And then I realized, oh no, you don't go with the defaults. You set it to a lower D type if you can, and you should for such a data set.
Yep, yeah, and there's a wonderful function that has floated around Kaggle for as long as possible, reduce mem usage, that goes through all of your pandas columns and turns them into the lowest memory setting that that column can handle. And it's little tricks like that that you pick up, you know.
Absolutely. Um, is there a strange trick in your current solution that worked surprisingly well?
Uh, I would say it was just strange how consistently batch norm models didn't work. Um, and I would say if I had had the intuition to just freeze batch norm, I would have said that would have been it. But I would say the strange trick that worked, the strange trick that actually worked was just how well pseudo labeling worked, because like I said, that target variable was so noisy. I did not expect it to work. I expected it to just add more noise to a solution and make my cross validation worse, because when I was pseudo labeling, the majority of my training data was actually from the previous competition. I think it was maybe 20% of the total data set that was actually from the current competition. So actually had a label on it. But there was a good blog post or Kaggle notebook that I found, again from Chris Diot, where he wrote about why pseudo labeling works. And I won't get into it, but it basically is super interesting to see that it's less about the accuracy of the target and more so about giving your model a better perspective on the landscape of potential training data, so it can slice it more effectively.
Got it. I don't see any other question, so I'll end up with the question which I always end up with. What's one best advice you would tell to someone who's just starting their journey?
Um, I'll turn it into two because I can't decide. But number one is take the cross validation, or the Fast AI course. Fast AI, if you can just take one course, it's the best. I mean, it's great. I don't know about the newest versions of it because I haven't perused those, but it's not just deep learning 0 to hero. It's generally programming and machine learning 0 to hero. I mean, he basically starts with very little assumption of Python knowledge, and you go from that to implementing a ton of PyTorch modules. Like if you don't know how nn.lstm works under the hood or the LSTM cell, it's because you didn't take the Fast AI course. So, he goes through everything from that to his wild take on Python and how you should be using it. And it teaches you so much about the language too. So, you have to be a good programmer. And the second bit that I kind of slide in at the end after I say that is model validation. Learn how to validate your models, or they're useless.
Awesome. You saved me the you saved me the effort of saying FASTA is the best deep learning course. So thanks for saying that.
And learn weights and biases. I mean, come on, how else are you gonna know what experiments work?
Thanks for the shout out.
Of course, of course, of course.
Anything we missed in the interview that you want to cover before we conclude the live stream?
I don't really think so. I think I'd just like to, thank 8451 one more time for really, taking somebody in who didn't really have much of a data science background at first, and helping mold me into the person I am now. Because Kaggle can teach you all the great things about modeling,
Yeah.
but there's so much about like data engineering that you just don't get on Kaggle. I would always resent when someone says that Kaggle isn't applicable to the real world, because I would say that you don't understand how important model validation is if you're saying that. But there's so much with like how you use databases and how you parse, billions of records in a data set, and things like that you just don't get as well in Kaggle.
Awesome. Thanks for that. I'll quickly mention that Mark is quite active on Twitter. You should follow him there. I won't say you can. He posts really insightful threads that I would highly encourage everyone to check out. Any other platforms that you want to highlight? I know you don't post as much on Kaggle. I hope you share your insights there as well. That might change, hopefully, if I can get you to do that.
Yeah, one of the issues with Twitter is that you have to fight with how much nuance to include in your posts when you only have 280 characters per tweet. And so that's why I like posting threads a lot, because I can write more. But inevitably, I leave a lot of details out. So I'm gonna introduce like a newsletter or a blog. It'll probably be one of those things to sort of maybe weekly or monthly wrap up a lot of the things that I tweeted about, things I saw, and just kind of put a bow on a lot of them. I don't have anything on that now, but I'll promote it on my Twitter page once I have it. So keep an eye out for that.
Amazing. With that, I'd love to wrap up the live stream. Mark, thank you so much again for such an insightful interview and sharing your solution, sharing your insights and tips that I think I always learn so much, but I hope the audience did learn a lot as well. And with that, I'd also love to thank everyone who is watching the recording or tuned in live. So thanks, everyone.
Yeah, thank you so much, Sanyam. It was a pleasure.
So thanks, everyone. Bye-bye.